All right, good afternoon, everyone. Can you hear me?
Yes, can hear you, sir.
Okay, thank you very much. All right, so okay, let's get on with today's topic, which is actually on. We have two sections to cover. One is very much on wired Ethernet LAN. We are going into local area network technologies, and we have two different types. One is very much on the wired LAN, which is very much based on Ethernet technology, and the other one is actually based on wireless LAN. Right, so we are going to talk about wired first before we enter wireless. Okay. All right. So for this part, we're going to talk about the standard. So it's all governed under the IEEE standard lah. Okay, you are not look at all the mostly the network technologies standard are mostly governed by the IEEE standard. That's why you will see the name IEEE appear quite a lot in the standard for different technology. For example, this one, the Ethernet technology is based on the IEEE 802 project.
Excuse me, sir.
Yeah, not sharing screen. Sorry. Okay.
Okay.
I always forget that part. Sorry. Okay. Let's start over again.
Yeah, now can see.
All right, good. Thanks for the reminder. Right, I think that's better. Yeah, at least you can see. Sorry. I was talking to myself and looking at my on screen. Yeah. All right, so it's very much on the IEEE standard. So you can see, when you see a word, something like IEEE 802, that is actually referring to the Ethernet technology. So there are many different others that you will see later. Okay, so this is the standard. And for the relationship, check this part. Yeah. Okay, so it is actually related to the OSI model, same thing. And for Ethernet, for the Ethernet technology, which is actually local area network technologies, the layer that is actually involved here is only the two lowest layer, layer 1 and layer 2. Okay, so see layer 1 defining what type of media to be used for this technology, and layer 2 defining all the logical link control as well as the media access control for this particular technology. So it's actually involving two layers, layer 1 and layer 2. So let me open up my chat box so that I can see exactly if there's anything. Yep. Okay. So you can look at the diagram here. So for the IEEE standard, they define for this particular technology, which is Ethernet, is just one type of LAN technology. There are many other types as well. For example, you can see from the diagram here, we will have, let me see, I put up a pen. We have Ethernet. Okay, so this is the Ethernet technology. And then we have token ring as well as a different technology. And then we have token bus and so on. But of course, those token ring, token bus, and so on, they are not popular. That's why today is mostly when you're actually looking for local area network equipment, they are mainly based on Ethernet standard, right? IEEE 802.3 standard, which is the Ethernet standard. And you hardly can find token ring, token bus type of local area network hardware anymore. Right, so I just giving you one example. That's why some of the standards that are actually more popular, they will continue to be available in the market. And then those that are getting outdated, they will start to disappear because less people wanted to manufacture that kind of technology. Okay, so that's why you will see them to disappear after some time. And of course, the functionality of all the functionality that we have been talking about of the layer 2 functionality that we're talking about in our previous learning unit. Okay, this also exists in Ethernet as well. So especially in layer 2, which layer 2 divided into two sections. One is logical link control. The other one is medium access control. right? So you can see that logical link control very much talking about the error control, okay, and then the frame type of stuff, and then flow control, and some others like medium access control. They're all done at the MAC sub layer. So they're divided into two sub layers here. And lastly is the physical layer. It's also covered under the Ethernet standard. So the Ethernet standard IEEE 802.3 also define physical layer. What are the physical medium that it can be used together with this particular standard, which is Ethernet. Of course, we have several types. And if you talk about the beginning of Ethernet technology, which is a local area network, this is the beginning. Beginning means what? When the computer was not even connected back in the 1970s. Only in the 1970s, computer was started to get connected. Okay, so this Ethernet technology was created back in 1976. Okay, at this place called the Xerox Palo Alto Research Center, PARC. And this is actually a famous, research center that if you still remember the story of Apple, this is the place where Steve Jobs visited and then to get inspired with the idea of Windows. Okay, this is the center who first started Windows based personal computer where they have the screen. Because last time you remember computers, all you have to type command line, CLI, you have to type all the command line in the black screen, that of things. So those are computers, But there is a time where, graphical user interface was first introduced, and then the personal computers start to have Windows. It is not from Microsoft actually, eventually. It is actually from this, they demonstrated the first personal computer that's come with what we call the graphical user interface, and then that come with a mouse as well. That the concept of mouse was first introduced, was first demonstrated, I would say, demonstrated by this Xerox, and then Steve Jobs from Apple, they visited this place, and then they get inspired by the graphical user interface and as well as the concept of mouse. That's why when they go back to their own company, they started their own research to produce their own version of a graphical user interface, their own version of Windows, so-called Windows, and also they designed their own mouse as well. So this is actually a very popular research centers during that times. But they are not really picking up after that. They must really know how to market the product very well. So obviously they do not do too well in this aspect. Right, so just some story to share with you. All right, so if you look at the different generation of Ethernet, we were actually first started with the standard Ethernet, which is actually come with 10 megabit per second only. And this is what we call the standard 802.3 Ethernet, which is running at 10 megabit per second only. It was some times ago. Then later they evolved into fast Ethernet, which is actually running at 100 megabit per second. And the standard also, a new standard created for this as well is called the IEEE 802.3U. Okay? 802.3U. So that is for the fast Ethernet. You can see the speed increases. The name also changes. And then today we will have the Gigabit Ethernet. Actually, Gigabit Ethernet is not new. So running at 1 gigabit per second. So this is actually come with a new standard as well, 802.3Z. And the more recent one is actually the 10 gigabit Ethernet, running at 10 gigabit per second. And this is what we call the 802.3AE. That's why I say, today most of our computers come with gigabit Ethernet, right? So it's actually downward compatible. So if you connect to a fast Ethernet network, it can also operate. It will be self-adjustable to actually adapt to what kind of standard that is being used in the network. If your networks, these are your network hardware. Each of the computers come with a network adapter, and then each of these network adapter will have to be complied to a standard. So if you buy a laptop today, or if you buy a new computer today, most of the time it will come with a Gigabit Ethernet port. So you will have the Gigabit Ethernet hardware that is compliant to the Gigabit Ethernet standard. So when your computer is connected to a gigabit switch, then it will be able to actually connect you at 1 gigabit per second. Right. So it's very much depending on the network devices, such as the switches that you are connecting to, and then what standard these switches actually comply to. So if the switch is just a fast Ethernet switch, so you have got a Gigabit Ethernet adapter on your computer. So when you connect the two together, so they can only run at fast Ethernet speed, which is 100 megabit per second. Right. So this standard actually downward compatible. Of course, some of the more advanced, more decent computer system will come with a 10 gigabits Ethernet, right? So you will be able to operate at 10 gigabit per second. This is local area network. This is not talking about the internet. Okay, you must not mistaken this one as the internet. The internet is actually one version of wide area network, which consists of many local area networks. Right? So you must be able to see this. These are two different technology. This technology is layer 1, layer 2, and the internet consists of layer 3. Right? The internet consists of layer 3. Okay? So it is slightly different network technology we are talking about here. Just don't get confused with Ethernet and the internet. Okay? Ethernet is a local area network technology. All right, now look at MAC sublayer. Okay? MAC stands for medium access control. So this is the algorithm to actually define who can use the physical media of the network. And so under this, they will also define the frame format. You still remember at layer 2, a frame format will be proposed. Different network technology will be using different frame format. So this is actually what you see here is actually the frame format for the Ethernet. So you will have these are your data is actually inside here inside the pink color box. The data will be inside the pink color box. So they have different field. That's why I said Ethernet technology define all these field. Different technology, different standard define different field. So this is actually one of the example. The example for the Ethernet frame. They also come with CRC, which is for error control as well. They got destination address, they got source address, then they got the type or length field, and so on. And if you look at data, for the data area, this is the pink color area. So the minimum payload. Payload is actually the data, the user data, right? The payload refer to the user data. So the payload size can be from 46 bytes to a maximum of 1500 bytes, okay, 1500 bytes. So the frame is actually of variable size. The frame can be bigger or longer or shorter depending on how much is the payload. Right? Payload is the load that is being carried by this particular frame. And yeah, so I just want to let you know that even for your IP packets, they also come with different length, especially for the data and payload field. Data and payload field, they will have different length as well. All right, and then one of the characteristics of layer 2 is actually you will have layer 2 address. These are the things that, that's why I said this learning unit here is basically demonstrating what you have learned in the previous learning unit on layer 2. Okay, so you will see addressing as well. So the addressing here used is actually a 48 bits address, and we call this MAC address. I think you are quite familiar with this MAC address. And MAC address also come with another name called the hardware address. Okay, it can be called the hardware address, the MAC address, or sometimes it is called the physical address. So it consists of 48 bits, which is actually expressed in 12 hexadecimal digit, as you can see from here. See, these are the 12 hexadigit. Each of the hexadigit is actually 4 bit. See, okay. Each of the hexadigit is actually 4 bit. How many of them? 12. 12 times 4 is actually 48 bit. Right? You know how this hexadigit is 4 bit, right? 2 power of 4 is equal to 16. Hexadigit has got 16 possibility, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no 10, huh? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So you have all the 16 possibility for hexa. And then in order to represent 16 possibility, you need 4 bit. 2 power of 4 is equal to 16. That's why each of the hexa character required 4 bits to represent. So how many hexa character do we have here? we have altogether 12. We have altogether 12 hexa character, and then it's altogether 48 bits. So you can actually divide into two. See, you can actually divide this one into two sections. The first section here, okay, the first section is actually referring to what we call the organizational identifier. Okay, organizational identifier is depending on this is to identify who are the manufacturer. Okay, the first half of the address is to identify who are the manufacturer. For example, HP is a manufacturer. All right, there was 3Com. Okay, sorry, 3Com was bought over by HP. There's no more 3Com already. For example, Cisco, TP-Link, D-Link. Okay, so these are the different manufacturers. They will have their own unique identifier, which is expressed in the first part of the address. And then the second part of the address here, okay, second part of the address is actually referring to the, the network interface itself. So they will have number for the network interface hardware. So all together form the MAC address, or we call it the physical address, or we call it the hardware address. So this thing come together with your network adapter. So if you change your network adapter, for example, you change your network adapter, the address will be changed. So this is the hardware address come inside the hardware. Normally, under normal circumstances, you cannot change this address. But of course, some of the hardware allow you to change the MAC address. But not all, but mostly you cannot change. When you change your network adapter, you will get a new MAC address that come with that particular hardware. Different hardware, different MAC address. Right? So that's the whole ideas about addressing. Okay, but you have to remember that this is the format. And if you want to find out this physical information, you can open up a terminal in your computer, or what we call the command prompt. If you are using Windows, you can, from your command prompt, you just type CMD. So you'll get a black screen with a prompt, and you type ipconfig. When you type ipconfig, then you will see this, the MAC address of your network adapter. If you have a network adapter that is wired, and you have a network adapter that is wireless, if you are using a laptop, then you will see two different addresses. Right? Because this address, this MAC address here is tied to the hardware. Tied to the network hardware, it's called the network adapter. So network adapter, you can change, you can upgrade. So when you change your network adapter, you change the MAC address as well. So this is the lowest address that you can find. And so the address will also tell us whether it is actually a unicast or it is actually a multicast address. Right, so to differentiate that, we look at the first byte of the address. So if you look at the first byte of the address here, and then if the least significant bit, the least significant bit of the first byte is actually 0, then there is a unicast address. If it is a 1, then there is a multicast address. So for you to differentiate whether this address is a unicast or a multicast, then you just need to look at the first byte, the least significant bit of the first byte, whether it's a 0 or 1. 0 means unicast. Unicast, it means only actually 1 to 1, only one recipient. Multicast, you have a group of recipients. So this address refers to a group of computer. And for broadcast address, it's referred to all the computer in the same network segment. Right? So when you actually send data to the broadcast address, then everyone in the same network segment will receive the same message. Right? Unicast is one-to-one communications. Multicast is actually, one to many, involving a group of address. Okay, so these are the examples that you have looked through. Then you know that how to differentiate which one is actually the unicast, which one is actually the multicast address. So you just need to look at the least significant bit of the first byte of the address. All right, so access method is one of the things that will help to decide, who now is whose turn to access the physical media. We all know that the physical media is actually shared by many stations. So how do you decide whose turn is it? You cannot use a die to just die and then, right? So they have a method called, the method that is used by Ethernet technology. The Ethernet standard is actually the CSMA/CD, which stands for Carrier Sense Multiple Access. with collision detection. Carrier sense, from the name, you know that you're sensing for carrier to allow multiple access. So if you just you just listen to the transmission medium, if you listen, the transmission medium is so quiet, no one is using it, then you can actually transmit your data into the transmission medium. This is how it works. When no one using it, you can actually transmit. But the thing is, when more than one station wanted to transmit at the same time, both of them also listening to the transmission media, isn't it? And the transmission media appear to be quiet to both of them. So both of them send their frame into the same transmission media at the same time, and that will cause collision, right? That's why carrier sense is not good enough. You need to have collision detection as well. You need to have collision detection. That's why all features to detect collision inside the transmission media. If there is collision detected, then they will actually fall back and then retransmit again. Right? So this is actually the technique. That's why it's called CSMS/CD. And then this is actually the multiple access technique used for wired Ethernet. For the wireless LAN, they are using a slightly different protocol because of the nature of the wireless environment is actually different. So they cannot use CSMS/CD, but they will, instead of using CSMS/CA, collision avoidance. This one is collision detection, to detect collision in the network. And collision avoidance is to avoid collision in the network. So that one is mainly used for a wireless network. Okay, so this is basically illustrating how this works. Whenever there is a collision detected, as you can see, because two machines is trying to send, A and B is trying to send. A and B also listen to the transmission media. The transmission media is always always idle. Okay, when it is idle, there is no one using. So both of them transmit their data frame into the transmission media, and that will cause collision because at one time you only allow one user to use, right? So now both also look at it, empty. So they go and use it at the same time, and they will create collisions. So when collision detected, so each of the station will actually go back and then set their own timer. Okay, and then this back off algorithm will kick in. So they have to wait for a random number of time before they can listen again to the channel. Of course, the clock is going to be different for A and D, and because of that, that's why A and D will never collide again. Okay, because they have to base on the clock for the delay. Let's say the A will be delayed for maybe 30 milliseconds, and then D will be delayed for maybe 50 milliseconds. So A will get to send first. After A waited for 30 milliseconds, then A can actually send into the transmission media. Right? So this is the way how they resolve collision inside a network. After all, we all know that computer network, they are all shared transmission medium. So even though they are shared, they must have a clever way to share as well. So they were using this CSMS/CD algorithm as the way how they share the transmission medium. Okay? Basically to resolve the collisions that happen because both using it at the same time. Right? All right, so now we look at the physical layer of the standard Ethernet. So there are actually 4 different types of common implementation for physical layer for Ethernet. One is 10^5. One is 10^2. You see the name, 10 base. This 10 refer to 10 megabit per second. Okay? 10^2 also refer to the same speed, 10 megabit per second. It's actually 10 M V P S. Okay? 10 megabit per second. So the same thing happened to the 10^T. Okay? 10^T also running at 10 megabit per second, but it is because it is T. T stands for twisted pair. So this one is using UTP. Okay, for the 10^5 and 10^2, they are using coaxial cable. Oops. They are using coaxial cable. These are coaxial cable. And then for the 10^F, they are using fiber optic. This is fiber. F is for fiber. T is for twisted pair. Twisted pair, you know, like copper cable, our standard copper network cable. So we have 4 implementation here, 4 type of implementation. But of course, the first 2 types, 10-5 and 10-2, they are getting less popular because nowadays no one using coaxial cable to be used as network transmission media anymore. It was last time, maybe 20 years ago, we are still using thin coaxial, right? But nowadays, mostly we are using 10-T, okay, which is twisted pair as well as fiber optics. And the same thing here, okay, based on our principle that we have studied for the OSI layer, for data to be carried by the physical layer, they must go through a line coding. A line coding technique. You still remember what is line coding? Coding. Line coding. So the line coding that's being used here is actually the Manchester coding. Okay, they're using the Manchester coding as a standard for the line coding. Of course, both transmitter and the receiver must using the same coding in order for them to actually be able to exchange information. And let's look at the 10-5 implementation. This is actually thick Ethernet, meaning to say the coaxial cable is actually thicker, so they can go up to 500 meters. Okay, the cable length can go up to 500 meters, and then the transceiver cable maximum 50 meters. This is the one. This is the cable. Okay, so they're using one piece of coaxial cable, and the performance is just 10 megabit per second. So this is, 10 megabit is nothing interesting in today's standard. It's way too slow in today's standard. Last time it was okay when you don't have a lot of things to send over the network. But today, our dependency on network is actually very high. Because of that, that's why 10 megabit per second is nothing. I think we are not interested. And let's look at another implementation which is using coaxial cable. It's called a thin Ethernet. This one is using a thinner Ethernet cable. This time you can only go up to 185 meters only. The previous one can go at 500 meters. So 10-2 is a cheaper implementation. So same thing, 10 megabit per second using baseband signal, and the maximum cable length of the coaxial cable is actually 185 meters. And now this is twisted pair implementation for Ethernet. So this is the most popular one at the moment. Most officers and small organizations are actually using this type of hardware. It's using twisted pair. So you will have a hub or a switch, a 10-T hub or 10-T switch. Then you connect. And of course, there is a maximum distance. Maximum distance is 100 meters. Okay, it's 100 meters. 100 meters is meaning from here to here. Okay, so this is actually 100 meters. Okay, the cable length from the network equipment such as hub or switches. And the 10-F is the same thing. You replace the cable with fiber optics, but the fiber optics has come with a transmit and receive. Let's say this is transmit TX. And then this one is definitely receive RX. Okay, one for transmit, one for receive. So this will make up the fiber implementation, also running at 10-F. Okay, so this is actually the diagram to illustrate the different technology here, and with the type of media that they are using, and what is the maximum length, and what kind of line coding that they are using for data exchange. So they are mostly using Manchester. Okay, and then the changes in the standard. Of course, we are trying to upgrade. You see, we are upgrade to a newer standard because 10 megabit per second is just not good enough in our context. So we will discuss about the different type of Ethernet setup. Right? First, we are talking about a bridge Ethernet. What is a bridge? You got two networks. You want to connect them together. Fine, you can using a bridge to connect them. So the bridge will create two different separate network here. Okay. And if you look at the diagram here, this bridge here that's being put on, Okay, it's connecting to 4 different networks. This is 1, 2, 3, 4. They connect to 4 different networks. So because they are using a bridge, so each of the domain, each of the network domain actually will contain their own broadcast within that network on it. Okay, so it's actually what we call a collision domain. In this diagram, they created 4 different collision domains. Okay, this one that you can see on top here, this one is just one collision domain. All the machine will have to take turn because the more, see this one inside here will have like 6 plus 6 or 12, 12 computers. So if you put all of them under the same domain without using a bridge to separate them, then they will have to wait for the transmission media to be clear before they can actually say anything. Because of so many people sharing, so the chances for you to use the transmission media is actually reduces. That's why this is also reduce your overall network performance. That's why I say this kind of network are not very popular. And the more popular setup is actually using a switch. Okay, when you have a switch setup, okay, each of the station on the Ethernet LAN to have the same capacity. You can see that this one, each of the switch, each of the port on the switch is a collision domain by itself. So depending on how many port your switch has got, like here in this case here, they got a 9 port. This means 9 collision domain. That's why the performance of the switches is actually much higher. There is no collision. Okay, there is no collision. Why? Because in one collision domain only got 1 computer. Okay? As you can see, okay, one collision domain only got 1 computer. That's why there is no collision, because on one computer collision only can appear if you have more than 1 computer. Apparently, this switch here is actually very powerful, very advanced. They actually can put each of the port as a separate collision domain. Okay, so each of the port on the switch is actually independent. That's why the performance of the switch is better than a hub. If you look at this one, okay, the hub is actually have to wait for everyone to clear. But this one, no need to wait. We just send because you are the only computers inside that particular domain. So this is actually the beauty of it. That's why switch has become so popular nowadays. And of course, we all have the full duplex and half duplex thingy. Okay, so if you are using a switch is a more advanced device, then you will achieve a full duplex switch Ethernet. So when you have a transmit and receive all can happen at the same time, this is called full duplex. Transmit and receive all happen at the same time. You are running on 2 pair of cable. So your capacity initially is 10 megabit per second only, but because you can run in full duplex, now you will have a capacity of 20 megabit per second. Why? 10 megabit going up, 10 megabit going down. So total is actually 20 megabit per second. Okay, for this particular case, because each of the computer is a collision domain by itself, so you do not need to have the CSMS/CB protocol running in the background, right? So no need to have that already. So each of them are actually individual. All right, let's move on to fast Ethernet, which is actually an improved version of the Ethernet technology. So this one is called fast Ethernet, running at speed of 100 megabit per second. Okay? So if you are using a hub, let's say, if you are using a hub, and you compare to you are using a switch, so you know that the hub can only do half duplex on it. Because hub is sharing, they cannot do transmit and receive all at the same time, you see. So hub is always a half duplex device. If you are using a switch, then it is a full duplex device. It allows both transmit and receive all happen at the same time. So they do not really share the port with any others. So in terms of the topology, you can see a point-to-point connection is like this. So you have a cable in between, actually interconnect them. But when you actually in a star topology, you are using a switch. So each of the computers has got their own connection to the same switch. So this is actually very much like a star. So it's actually a star topology. Okay, the fast Ethernet implementation has got 3 examples here. It's 100. You can see that this one is 100 base TX. So from your mind, you know that this 100 refer to 100 megabit per second. And then this TX, because they got a T here, so this one has to be, T stands for twisted pair. UTP is a twisted pair. And then you look at the second one, it's also 100 base FX. So the one in front is the same, 100 megabit, but FX here, meaning to say they are using fiber optics. Okay, they are using fiber optics as the transmission medium. So F is fiber, T is twisted pair, which is stand for UTP. And how about the 10-T4? They uses more wires for the UTP. Instead of normally people using 2 pair, but for 10-T4, they can use up to, it can use up to 4 pair of cable, right? So the more cable they are using, that's why they are slightly better, but the cost is higher. So now today we come back to the Gigabit Ethernet, which is actually become a norm in today's standard. Today you actually buy a computer, sure, they're going to come with Gigabit Ethernet. I know some of the laptop is because they are so thin, they do not come with a physical Gigabit Ethernet. Right? So if you talk about Gigabit Ethernet, it's actually something like this. Like if you look at the video, so these are the things that actually what we call the USB type of network adapter. You can just using this plug this device into the USB port of your laptop. Then you immediately has got a Ethernet wired LAN. So this is the adapter, external adapter through USB. Okay, so it's all go back to the half duplex and full duplex thingy. So when it is full duplex, the station can transmit and receive all at the same time. So then you do not need to use the MAC protocol. So if it is half duplex, you have to use the MAC. So it's not the MAC protocol, the medium access control protocol such as CSMA/CD. Okay? Full duplex no need because no one compete with you, no one is going to collide. Each of the port is a collision domain by itself. So they will not collide each other across domain. No, that will not happen. But if it is a half duplex, everyone sharing without boundary, so sure you will need CSMA/CD to help you to regulate. Okay, now it's whose turn to use the transmission media, right? So you can see the difference. And then because of that as well, nowadays switches are actually much more popular as compared to hub. Hub is low tech, and furthermore, the performance also not good. That's why people nowadays have been going for switch. Has been going for switch. Okay. And then they were not using CSMA/CD. Okay, so these are the different topology. These are the things that you can set up using for the Ethernet, for the Gigabit Ethernet. Not only limited to Gigabit Ethernet, not only limited to Gigabit Ethernet, but they can also use for other Ethernet as well, like fast Ethernet and the standard Ethernet. All right, so for this one, the Gigabit Ethernet implementation, they got 4 different types. 1000 SX. Okay, here 1000 refer to 1 gigabit per second. And then XX, this one is referred to fiber optics. One is shortwave fiber, multi-mode fiber using SX. And then you have LX, that is actually using a single mode fiber. As you can still recall, single mode fiber has got longer distance. Has a longer effective distance as compared to multi-mode fiber, which is only a few hundred meters, maybe 500 to 600 meters only. But for single mode fiber, they can go up to 10 or 20 kilometers. The length, one stretch is actually 10 to 20 kilometers. And of course, you can also always use the UTP. Okay? This is actually using 2 pair of 2 wires of SDP. The shielded SDP, 10-CX, and of course for UTP, you will have the 1000-T. And so that is actually using a slightly different standard. But the cable are more or less the same. It's just the configuration of the cable, they are slightly different. Okay, so these are actually the comparison and its usage. You all know that different network technology has been used for different purposes. And older, when your network is getting old, of course, it cannot meet the needs of your today's requirement. Just like myself, you see, because I implemented my own home wired networks. That was 15 years ago in my own home. So I using fast Ethernet. Okay, so I was using fast Ethernet implementation over the UTP cable. So I was basically implementing 100 base TX type of implementation. And during that time, why I didn't go for Gigabit Ethernet? Gigabit Ethernet already available in the market, but they are more expensive, way more expensive. So to me, I think I do not want to spend so much money. And then furthermore, during that time, our internet gateway is only a maximum of 8 megabit per second, only 8 megabit compared to 100 megabit. Of course, my 100 megabit home network is going to be sufficient, for my purpose, because the internet gateway is only 8 megabit per second only, right? So no matter how fast is your local area network, so it will not go beyond what the internet gateway. This is internet subscription from ISP, such as TM. During the time, it was Streamix maximum running 8 megabit per second only. That's why I implemented my home network. 100 megabit is more than sufficient. But after 15 years, when the internet service provider nowadays can actually provide you with 100, 300 megabit per second, 500 megabit per second, 800 megabit per second. Now, if you are subscribing to a 300 megabit per second type of internet gateway and your home network, which is actually your home local area network, your home Ethernet is still running at 100 megabit per second, then you cannot fully utilize your internet subscription. Because your internet subscription is you subscribe for 300, right? But fast Ethernet maximum is only 100 only. So you can never fully utilize your internet subscriptions. So because of that, you will have to upgrade to Gigabit Ethernet. So when you upgrade to Gigabit Ethernet as your local area network, you are running at 1000 megabit per second. 1 gigabit per second is equivalent to 1000 megabit per second. Okay, so now we have 1000 versus maybe 300 megabit per second of your ISP internet gateway. So it's sufficient. That's why today I will have to upgrade my networks to Gigabit Ethernet. Right. So what should I do? I just change the switch. Last time I was using a fast Ethernet switch. Now I just need to replace the switch with a Gigabit switch. And of course, the cable that I'm using, last time I was using Cat5. Cat5 has got a speed limit. It has got a speed limit of 100 megabit per second. And that's why I have to upgrade the cable as well, you see. So I have to upgrade to at least Cat5e or Cat6. Right? So these are more expensive cable. So they will be able to easily do Gigabit connection speed. And these are the application. End user usually, they use a slower speed. And when you use it for the backbone, interconnecting backbone devices, you want to use, Gigabit, Okay, so these are the things. Also, these are the different applications that you can see. So as I say, it is not fixed now, to say, end user must use the slower speed. Of course, if end user are rich enough, you can always provision some future-proof type of technology, which is actually much more expensive. I mean, if you have got a budget, then that is fine. Okay, if you want to run economics, then you go for the highest connection speed with the most economic price tag. Okay, just like myself, 15 years ago, the most economic is fast Ethernet. Gigabit Ethernet during the time was quite expensive. So I want to go economy. So I just implemented the fast Ethernet. But after 15 years, then that the fast Ethernet is no longer can fulfill my needs. So I need a higher speed local area network. So I upgrade my network from fast Ethernet to Gigabit Ethernet. Okay, so I hope that I'm actually getting you the picture clear. Right, so some of the Ethernet success factor. Okay, why Ethernet is just one of the local network technologies, and then why Ethernet is so successful as compared to other local area network technologies. Okay, because they offer, first thing is because they offer high-speed network connectivity. Last time only 10, now they move to 100, move to 1000. Now they can do 10,000 megabit per second, which is 10 gigabit per second. So this is actually very tempting for a lot of people. And then you do not need to spend so much money. Yet, Ethernet technology are actually cheap. So for a Gigabit Ethernet switch now today, you can get like maybe just 100, less, depending on how many ports lah. If you are running just a 5-port Ethernet switch, so a 5-port gigabit Ethernet switch is probably cost you like something like maybe 50 ringgit, 50 to 60 ringgit. So it's considered quite cheap. And then simplicity, easy to maintain. So these are also, very easy. Scalability also, very easily done on Ethernet. Reliability, they are very reliable. That's why a lot of local area networks are actually using this technology. And then, of course, more importantly, it's actually very low cost to implement and to install and to upgrade as well. So these are the success factor. As compared to other type of network, local area network technologies, this is actually the advantage of Ethernet. That's why they become so popular nowadays. All right. So in summary, you all know that all the different type of technology come with their own respective standard, and then they all come in different speeds, and then riding on different transmission media, riding from the outdated coaxial cable, then go into the UTP cable, and again that UTP cable has got different category, right? It's all started from at least Cat 5. Okay, don't talk about the Cat 4, Cat 3 lah. Cat 4, Cat 3 type of cable are only used for telephone networks only. The old telephone networks, they use Cat 3 or sometimes Cat 2 type of UTP cable. Those are also UTP cable. Those cable that your telephone company pull to your house, and those couple cable are actually UTP cable as well. But they are lower performance, mainly designed to carry our voice. But for data network, it's actually starting from category number 5. You have category number 5, 5E, 6, 6A, 7, and now is 8, category 8. Whereas category 7 and 8 are actually quite rare because they are very expensive. Giving it some time, then they will become cheap after some time. Just like category 6, it was very expensive, but now category 6 are very cheap. Okay, so these are the things that I want to convey for the wired part. So now I will do let me stop setting first, and then I will like to stop this presentation, and then I will switch windows to the wireless network, and I will share again. Okay, now I share again on the other screen too. Okay, so this one is actually our second part of the learning unit. It is actually very much on the wireless networks. Okay, and that Ethernet technology was first started using wired. They are getting very popular. And then back in 1997, that was more than 20 years ago, they start to finalize a standard for wireless networks. I still remember when I was also the time when I actually started my research on wireless network. During that time, it was 1996. So during that time, this wireless network standard hasn't been finalized yet, but we already have the hardware to play with. Because I started wireless network research back in 1996. So that was quite some time ago. And now it starts to evolve into what you have today. It's what we call Wi-Fi. Okay, they come in today we're going to cover two different types of wireless network. One is the 802.11, which is the wireless LAN. You call it the Wi-Fi. And then the other type is actually Bluetooth. I think Bluetooth is just a slightly different standard. They run on the same frequency, but different mechanism. So, of course, because they are different, so they come with different IEEE standard, like 802.11 802.15 for Bluetooth, 802.11 for wireless LAN, Wi-Fi. And as we all know that, the advantage of wireless technologies is all about, allow you to wirelessly connect to any device. It's so convenient. I think you like wireless. Today, you actually mainly using wireless networks a lot of times. If you are owning a smart device, like your tablet or your smartphone, most of the time your network connection are actually gathered from a wireless network. It's either from a Wi-Fi, which is a wireless local area network, or you are getting it from wireless broadband network. Okay, the example of wireless broadband network is such as your 3G, 4G, and 5G network. Right? These are actually the mobile cellular network. It's a mobile network, and it is different from your wireless LAN, wireless local area network, different from your Wi-Fi. So those are different type of technology. Again, different type of wireless technology. That is mainly used for mobile phone, mobile devices. The mobile phone started with the analog first generation, then later evolved into 2G. I think you are still using it until today, 2G GSM, 2G GSM. And then later they said 2G is too slow to deliver data. So now, then in the year 2000, they introduced 3G, okay, 3G mobile network that can deliver faster data up to 2 megabit per second. But again, 2 megabit per second is nothing, It's nothing grand. After some time, people still not happy with it. So they introduced 4G, 4G mobile network. It's called the 4G LTE, long-term evolution. So when you hear the word LTE or 4G, they refer to the same thing. Okay, so they go into the fourth generation network, and then they will offer you quite a significant increase in your data transfer rate. And then, of course, today you are waiting for the 5G mobile network to be implemented so that you can connect to the 5G network. Okay, I think for Malaysia, by the year 2024, you should, the coverage of 5G should achieve up to 80% of the populated area. At the moment, they are already start implementing it, but of course, implementation needs time. You need to put up all the base station kind of things. So it will take a few years to implement before it is fully available to everyone. Okay, so their target is by the year 2024, at least 80% of the populated area will be covered by 5G. And of course, last year, our government has decided to actually stop the 3G service altogether. So you won't have any 3G service in Malaysia. All the operator will stop their 3G service. That's why nowadays when you go to a place where 4G doesn't work, then you try to switch it back to 3G. You cannot do that anymore, right? Last time we have a choice that, if actually, 4G doesn't work, we can still fall back to 3G network and you can still get connected. You got options. But today your options supposed to be 4G and 5G, but 5G is still not fully implemented yet. So leaving you with only one option, which is just 4G. So if you are not lucky, you go to an area where they got poor 4G service, then you may get cut off. Just like myself. I think last Saturday I went to this shopping mall, and I think my mobile service was quite poor, and suddenly I was, there are service intermittents. So a certain area I got connection, certain area I don't have connection. So when I want to make payment using my e-wallet, and I couldn't have any data network running on my smart device, so I couldn't make payment. I was quite pissed off. Yeah. So that's why I said last time when the same thing happened, I can always change my mobile setting to 3G, so I can still fall back to the 3G network, which is working for at that area. So I can still switch between 3G and 4G to actually get my mobile network connection. But now 3G all stop already. Now you don't have options. So if your 4G doesn't work, that means it doesn't work. So good luck. So we really need to have a lot of labs for this. All right. So wireless application, as I mentioned to you, there are many wireless applications that you can do. Everything go wireless nowadays, basically. So if you, whatever computing device that you are buying, they all come with wireless capability. It's either Wi-Fi or Bluetooth. So they should have all these things. But again, now, Wi-Fi networks, if you have used it enough, then you will start to realize that, Wi-Fi network, after all, it is not that great, at least the reliability and availability of the wireless network is not always consistent. Okay, it's not as reliable as the wired Ethernet, but you can get the flexibility of moving around without tied down by the cable. Right? Give and take lah. You get the advantage. Of course, you pick up these are pro and cons, right? So nothing is perfect here. So you want mobility, you want to be able to move around without being tied down by the cable. So you will actually receive poorer performance. Okay? But of course, you want a higher performance and more reliable type of network, you use wired Ethernet. Okay? You use wired Ethernet, plug in the cable. But once you plug in the cable, you cannot freely move around. You see, you have to tie down to a place. So these are pro and cons lah, give and take lah. So that's why we do not say which one is a better network technology. They will serve a different purpose. Okay, so we will have different type of wired and wireless network technologies. This is actually the isolated LAN for the wired. So if you look at the wireless one, they do not have any physical connection. They're all using radio frequency to talk to each other. Okay? And for the wired Ethernet, you will have a switch, a router where all the computers connected using cable connected to the switch, and the switch connect to the routers. This is the routers. Oops, sorry. I have to. This is the routers. This one. Okay, this is the routers. And then for the wireless network, so you just need to have an access point, a wireless access point. So all of them communicate in wireless, but they still go through a routers. Your access point connect to a routers, so they can connect to a wired internet. Internet are mostly wired. The core of the internet are mostly wired. It's only at the edge of the internet they were using wireless technology to allow user to connect. So these are the differences. But all the other things are actually the same. And then because of you are using radio frequency as the transmission medium, you don't have something physical. So your signal, your wireless signal, actually subject to some of this problem lah. Greater attenuation, greater interference of signal, greater multipath propagation. These are the signal path get reflected problems. Because your signal is out there in the air, that's why you cannot control where your signal is going to go, you see. So when you actually, radiate your signal into the open air, so you cannot control the direction of you cannot really control too much on the signal itself. So that's why you will pick up multipath, you will pick up noise from the environment as well. So these are the problems that the wireless local area networks technology will have to deal with, you see. So they are more problematic. Because of they are subject to more problem, that's why your network will come with a lot of problem, more problem as compared to wired network. So in terms of the reliability, it is less reliable. Okay, in terms of access control, we also come up with the same problem because the air is shared by everyone, the same medium. Air is actually shared, and you cannot use different cable to differentiate because the air, you transmit, I transmit, just like when all of you go into the hall, everyone start talking. You will hear each other's one for sure. Okay, if we're all in the same room and all of us start talking, then you will hear each other's, and then what you hear each other is actually the noise that will cause distortion and all the stuff, cause errors and all those things. That's why we need to have an algorithm to decide now whose turn to talk. Okay, now whose turn to talk, so that we don't overlap each other's, we don't interfere each other's. That's why you need to take turn to talk. So when someone is talking, you cannot talk. You have to listen until it is your turn to actually talk. So how to decide? We are using an algorithm called CSMA as well, but this one we don't use CSMA/CD because CSMA/CD is not fit the purpose. It doesn't fit the purpose. So we are using the problem. Okay, before we talk about the new medium access control, we have to talk about the problem of the current one. So if you have A and B, B can only see A only. If you can see this diagram, the station B will only see A. Okay, B do not have enough coverage to see C. They won't see C, but A can see both B and C. So when B and C wanted to transmit to A, so they cannot listen to each other's because they cannot see each other, right? And then because of that, so B and C will transmit at the same time to A, so they will cause collisions. So this sort of thing is called the hidden station problem, right? So in a wireless network, that's why some of the protocols are not suitable. So this is also the same thing. That's why we need to use a new protocol, what we call the CSMA/CA, collision avoidance. Okay, we're using collision avoidance to avoid the collision, meaning to say, if you want to send to someone, so you have to send out a signal, say, hey, I have something to say. Can I say it? So you send out a RTS to request to send, and then your recipient will tell you that, oh, it is clear to send. Okay, so when you receive a clear to send from your recipient, then you will only start sending. If you do not receive a clear to send, then you cannot send, you see. Okay, so this is the extra mechanism that's come with this CSMA/CA algorithm. Right, so I don't want to talk too much about this because this can actually be very detailed if you want to talk about this. All right, so let's talk about the standard. Right? It is actually fall under the 802.11. Of course, 0.11 is the general one. For wireless LAN, they do have other variants. Okay, just like just now, 802.3, you got 802.3 Z, 3U, okay, 3AE. So those are actually the variant of 802.3 Ethernet. So for IEEE.802.11, so they also cover both physical and the data link layer, layer 1 and layer 2. So another name for this wireless LAN is called the Wi-Fi. So they come in two different types of service. One is the basic service set, BSS. The other one is extended service set. So what it is all about? So it is actually based on the architectures. So if you have a simple wireless network, a simple wireless network like this, okay, one access point, and a few, computers to connect to this wireless access point. So this kind of setup is called the basic service set. Or if you are using the more ad hoc method, you don't want to use any, access point, you can also talk to each other in a small group, meaning to say that a few of you gather together, bring your laptop, you can also communicate with each other using the ad hoc mode. The one that I'm talking about here, this is ad hoc mode, and this is the one with AP one is actually infrastructure mode. So either way, you can actually communicate. So these are the simple network, and we call each of these a basic service set. So when we actually expand our wireless network, so you can see multiple BSS. This one is one BSS. Okay, this one is another one BSS. So when you have multiple BSS interconnect by a distribution system, which is another network. This is another Ethernet. It could be an Ethernet network. So interconnect together. So the whole thing here is called the extended service set. This whole thing here. Okay, this whole thing here is actually called extended service set. So meaning to say an extended service set is consists of multiple wireless access point, linked together. So if you actually come back to Unimast, and you will see that the Unimast Wi-Fi services are actually based on the extended service set, right? So you have multiple access point deployed across the campus, so you can still using the same login ID, to actually connect to the Unimast network. All right, let's look at the MAC layer. Of course, the MAC layer will have their own different functionality, I would say. Okay. Okay. So they will have ALC layer as well, and they will have the MAC layer. The MAC layer have two different function, and the physical layer here. Okay, they got different type of physical layer as well. They can have the FHSS stand for frequency hopping spread spectrum. So the name is so long, but it's actually these two is actually refer to CDMA. If you have CDMA, you have CDMA. Okay, this is refer to CDMA. Okay, so these are the CDMA technique. Two different types. One is frequency hopping spread spectrum. The other one is direct sequence spread spectrum. Right. Of course, your wireless LAN also come with infrared, which is not very popular. Okay, and then these are all under 802.11. 802.11 define three different types. And these are actually the same type, but they're just different physical media is different. And then we have a different type is 802.11a. Okay, 11a also got two different types. One is DSSS, direct sequence spectrum, and the other one is OFDM. Now, OFDM is broadband technology. It's called orthogonal frequency division multiplexing. That's why I say, I mean, these are very technical things. That's why I do not want to discuss it here. I just want you to know that different standard, they may adopt different technology. Okay, slightly different technology. So in order for the two wireless device to be able to talk to each other, they must set it to the same standard. They must set it to the same standard. Let's say you want to use 802.11a to communicate, then both access point and the computer will have to set it to use the same standard 802.11a. Okay, for them to actually communicate. And if you look at OFDM is actually one of the very promising broadband technology that has been used everywhere. That's why it has been also adopted for all the new standard, all the new Wi-Fi standard. They're all based on OFDM. And OFDM was my PhD topic. I did a PhD in OFDM. It was about 20 years ago. So, so it's a long history. All right. So, and then we will have standard on 11G. Okay, it's running on DSSS as well. Okay? Direct sequence spectrum. Of course, we have some other newer standard as well. Apart from A, 11 first, then 11A, then you have B and G and so on. So if you look at this diagram here, so you can see these are some of the more recent standard, newer standard. Nowadays, new actually at least started with 11N. You do not want to talk about 11. 11 already obsolete. No one produce 11 equipment anymore. But 11A still there, but please do not use 11A. Do not use 11G. Do not use 11B. So those are outdated type of Wi-Fi standard. Why they are outdated? Because they are slow. They are extremely slow. Okay, they are extremely slow. 802.11, the earliest version, 802.11 offer only 2 megabit per second. And then 11A, 54 megabit per second. 11B also, 11B is actually only 11 megabit per second. Then 11G is actually 54 megabit per second. It's all less on 100 megabit per second. Okay. So 11N is a different story. 11N, they started with 150 megabit per second and then multiply by how many antenna you have. That's right, how many stream you can have. So you can multiply. So based on this 150 multiplied by 4, then you get like 600 megabit per second. That's why if you have Wi-Fi to use, if you have Wi-Fi network to set up, it is better for you to start off with 11N at least. And then there is a more powerful, more high-speed version, 11AC, which is running at 5 gigahertz. 5 gigahertz. So this one is also very high performance, but it's running at different frequency. You can see 11N, 2.4 and 5 gigahertz, but this one only 5 gigahertz only, 11AC. So some of your laptop may have this 11AC standard, and you can call it a Wi-Fi 5. And today, The most recent standard is the 802.11ax, which is actually, in short, we call it the Wi-Fi 6. So when you actually look at some of the advertising advertisement out there that people talking about, oh, we are running on Wi-Fi 6, things like that. Yeah, this is a new standard. It's running on both 2.4 and 5 gigahertz. And then Wi-Fi 6 offer even better performance, not only MIMO, but they offer even greater separation of interference. You can call it like Wi-Fi 6 start to have color. You remember last time, long time ago, when we watch TV, our TV is black and white, right? People say black and white is no color. Then after some time, people introduce color TV, right? So you can see that Wi-Fi 6 is actually start to have color because they can use different color to differentiate different network. And before Wi-Fi 6, these are all, something like a black and white TV, black and white, they do not have colors. So this is actually something for the layman to understand. That's why Wi-Fi 6 actually be able to mitigate interference better than the older standard. But again, for you to connect, even if you buy a wireless access point or you buy a Wi-Fi router that support Wi-Fi 6, but you have to make sure your computer and your smart device also support Wi-Fi 6. So if your device do not support Wi-Fi 6, they will always fall back to the older standard. Okay, even you are using a Wi-Fi 6 router, but you will still be fall back to Wi-Fi 5 or Wi-Fi 4. Okay, if your device is older, do not support Wi-Fi 6. Right? So this is actually the difference. That's why the one that I'm showing you here is actually the more decent Wi-Fi standard that you should be using, rather than some of the old one like 11, 11B, A, and G. Okay, BGN, not BGN, ABG. You should just forget about them. They are too low performance. And of course, there are new standard being introduced for wider coverage like 11AD, 11AH, and even 11AF. So you can see from the diagram here, 11AF will have very wide coverage, 11AH. Okay, so these are the things. So they use 11AF and 11AH for rural type of application. Rural. And of course, some of the IoT are also using 11AF or 11AH. Okay, that of frequency. So a lot of IoT also come with Wi-Fi, isn't it? So your Wi-Fi standard. That's why it's actually a very complicated and sophisticated when you talk about wireless local area networks. They have a lot of things here. And if you look at the evolution of the Wi-Fi standard here, you can see, not be surprised to see, initially we are running on 2.4, and now 2.4 already running out of spectrum, so we migrate to 5 gigahertz. And 5 gigahertz, we are still not happy with the speed. You have to go to a higher frequency, 60 gigahertz. Of course, at 60 gigahertz, you will be able to transmit even higher bandwidth, higher speed. So as you increase the frequency, okay, you will be able to transmit at even higher speed. And of course, Wi-Fi do not started from 2.4. It's actually Wi-Fi started from 900. Okay, there's a version called 900 megahertz. 900 megahertz. So that is actually the first one, but it is not available in Malaysia because our Malaysia government do not acknowledge, okay, do not regulate the 900. 900 is not made available in Malaysia. That's why we do not have any Wi-Fi running on 900 megahertz. But for your information, the equipment that I was playing with, that was 25 years ago, it was 900 megahertz wireless LAN device. So these are the evolution. You can see the standard, the standard 11N, 11N, and 11AC. Okay, 11AX here, AC here, 11N is here. Okay, so you can see the evolution and the increase of speed. Okay, the increase of speed along the way. And someone is even proposing Wi-Fi 7 now, but it will not be finalized until the year 2024. Okay, so it is too early to talk about those things. Okay, so this is just for your reference. So if you want to have high performance, you have to connect to a higher frequency. For example, 5 gigahertz. 60 gigahertz is quite rare. Okay, The most popular one is 2.4, but 2.4 too many equipment running on 2.4, so your bandwidth also limited. That's why your 2.4 gigahertz Wi-Fi cannot offer you extremely fast connection. If you want something even faster for your video, for your deep video or for your online gaming, then you've got to go for the 5 gigahertz standard, either 11AC, 11N, or 11AX. Okay. And this is another example of the evolution of the standard. So this is just for your reference. This is starting from the 97 until maybe 2019, which is Wi-Fi 6. Okay, Wi-Fi 6 is in 2019, the 6th generation. All right, Bluetooth. I think Bluetooth is something no stranger to all of you, but just for your information, Bluetooth also running at 2.4 gigahertz. Even though they run in a different standard, when they can share 2.4 gigahertz. Why 2.4 again? You see, because 2.4 is a free band. You know that if you have a wireless equipment that want to transmit frequency, you must pay for license. It is not simply that you want to transmit, that you can transmit. You have to pay for license. Because of you don't have the license, then you cannot transmit. Then a government make 2.4 as a ISM band, a free to use band. So everyone build the equipment running on 2.4. You don't have to pay. You don't have to pay for the license fees. That's why you can see a lot of things running at 2.4 gigahertz. So Bluetooth is one of them. You know the usage of Bluetooth, right? You have a lot of Bluetooth earphone Bluetooth mouse Bluetooth speaker all those things are same thing. So you have been using it a long time. Okay? So Bluetooth is not a technology called Gigabit. It's actually a name of someone. Bluetooth. So it is not technology Gigabit. So no, it's not such thing. There's a wrong translation. Okay? It's a name of someone. All right, so mainly for short distance, I would say Bluetooth mainly for personal area network, PAN, personal area network. For short distance, that means usually up to 10 meters. Most of the typical application is up to 10 meters only for you to interconnect all your personal belongings, such as your earphone, your speaker, your printers, and all the stuff in short range to give you the convenience for cable replacement. Okay, to allow you to replace your cable. Okay, so allow you to replace your cable. Okay. And then the application, I don't want to talk too much about the application. Wireless mouse, keyboard, and all those things are very common Bluetooth application. And then Bluetooth come in 3 different types of network. They are not very popular for to use it as a data network until today. So they can form a Piconet, consists of 8 devices. They can even combine multiple Piconet together to form a scatternet. And then they can even use it for the low rate wireless application like LR, wireless personal area network. So I would say mostly it's actually the Piconet. So these are actually multiple devices, up to 8 devices, 1 master, 7 slave, all connect together, or under the primary and secondary. Okay, but this type of network are not very popular, to be honest to you. Okay, it is not very popular. Not many people using it because these are very low performance networks. I think the transfer rate is go up to 1 megabit per second. 1 megabit compared to your Wi-Fi is nothing. So I don't think you'll be interested to use Bluetooth as your network. Okay, Bluetooth as your network is not fast enough in today's standard. But if you use it for your earphone, for your keyboard, for your mouse, that is wonderful. Okay, so this is actually a Piconet, 1 primary and multiple secondary to form a network, so you can share data through this type of structure. So if you want to build a bigger network, you can build a scatternet. So a scatternet is actually consists of more than 1 Piconet interconnected by an intermediate Bluetooth station. For example, this one. So this is interconnecting 2 Piconet, this Piconet number 1 and Piconet number 2. Okay. So this is how it works. But hardly people use this one to form a network. One thing is that the performance is really not up to the standard for data transfer. Data transfer, you need something faster. Even though you downloaded your picture using Bluetooth, it's going to be slow as well, you know. When you take a picture, you want to use Bluetooth to send it to your friend, to transfer to your friends using Bluetooth. That will also take some time for you to deliver. That's why I said this is not a very popular option for computer network. Right, so they run at 2.4 and Bluetooth come in different classes. Again, version 1 to 3 running at 1 megabit per second. Okay, and then powers up to 10 meters. And then there are newer version of Bluetooth like version 4 to version 5. Generally, they also run at 1 megabits, and then version 5, they can maximum go 2 megabit per second. But 2 megabit per second is still nothing compared to what the Wi-Fi can offer. Wi-Fi can offer you hundreds of megabits per second. You know, now today Wi-Fi can offer you up to gigabit per second. So 2 megabits is nothing lah. Okay, that's why they are not very popular. They're only mainly used to connect your speaker lah, connect your mouse, connect your phone, type of things. All right. So that's all for my highlights on the units. So is there any questions? Any question that you would like to ask? Anything? Are you still with me? Okay, or no question. Okay, I can see the message now. Okay, no question, fine. Okay, so if there's no question, fine. Okay, I hope I can my explanation can enlighten you on to add on to what the video lectures has got. And please be reminded that everyone now we still have 2 more Saturdays that you will have quiz that you need to come and sit. Okay, take the quiz for each of the Saturdays. We still have 2 more quiz after quiz number 3 and quiz number 4 and quiz number 5 to come. So make sure on Saturday you do not miss out your quiz because your quiz do take into account of your mark. All right. So if there's nothing, I think today we spent like 1.5 hours to talk about 2 units, one wired LAN technology and wireless LAN technology. Okay, so I hope this will give you a clear idea. Of course, these are mainly surface. Hopefully later on in your future course, you will be able to pick up more technologies, more details. Okay, so these are just very much introductions. Okay, so if there's no question, I think that's all for today. And have a nice holiday for some of you who are celebrating Gawai and Gamatan from Sabah, and enjoy your holidays. Okay, that's all. If you some of you, if you still want to scan your attendance, let me share the attendance again. If you've done your attendance, then you may. Okay. Oops. If you've done your attendance, then you can actually leave. So I will see you again next week. Bye-bye.
Thank you, sir.
Yeah, thank you.